Hello. Okay, so let's get started. Welcome everyone coming to our week 7 lecture. Um, we hope you had a good break in week 6 and catch up with everything in the first half of the term and making progress towards your projects. So this week's lecture, we will be talking about two more topics on correctness. So on testing on correctness. So the first one will be about exceptions, and the second one will be code coverage. So we'll be talking about these two topics today. And for tomorrow, we are going to have in-person lecture again in the Science Theater, and we'll be talking about deployment and conceptual modeling. Okay, so this is what we are going to talk about this week. So let's get started with the very first topic, which is exceptions. So this is another topic about correctness. So exceptions and code coverage. So these two topics that we talk about today will be the final two topics on correctness, and then we'll move on to other topics. Okay. Okay, so exceptions. So why? So again, we'll be first talking about why, like why we have the exceptions, and then we'll explain what is exceptions and how we raise and catch exceptions. Okay, so this is the structure. Okay, so before we explain what is exceptions, let's first have a look at this example. So let's have a look at a code here. And then we'll explain like why we need exceptions. Okay, so let's look at this code line by line. So the first part here, which is import prompt from PromptSync, and then we have a prompt func equal to prompt. So you might have seen this before in labs, but I will again explain it here. So what this part, what prompt does is that we are getting user inputs. So it helps us get user inputs. And to be able to use prompt, we need to install. So you need to, in your terminal, npm install prompt sync. So it's a npm library, so we need to install it from npm install. And because we are here in a TypeScript file, so we also need to have another thing, which is npm save. So you save the add tabs. So we have used this for a couple of times, prompt sync. So what this second command line like help us is to, this package contains the tab definitions for prompt sync. So to be able to use prompt, we need to npm install prompt sync and also get the tab package for it. And you need to do it in your terminal, okay? Yeah, so this helps us to get user input. So let's have look at the second part here. So it's helping us get the square root of number x, and then we calculate the mass power. So what it does here is return the value of a base raised to a power. So this function like is calculating the square root. Okay. Okay, let's have a try this code and see how it works. So npm run tsnode and this file name. Okay, so it asks us to enter a number. So this is here, like input prompt func, please enter a number. So let's have a try 4, and it should console log the square root of 4, which should be 2. Okay, so this is how this code works. Okay, so you might have think like, what if I enter, put in some number that is negative? So what if I put in a number such as -4, right? Nah, it doesn't work, right? Because we need to have some positive inputs here. So, so you might have think like, how can I deal with it? Like maybe I should try to have a condition here. So perhaps we need to make sure x needs to be above 0, more than like above 0, or we can see like if x is smaller than 0, like it's negative, then we console an error message and say you need to have an input that is above 0. Okay, so what we are going to have here, perhaps we can have something like if x is negative, and then we have something like we console error, and we put in an error message. For example, we can have error input. Okay, and then we need to terminate this code, right? Because we do not need to continue with calculating the square root of it. Okay, so we process exit. Okay, so let's have a try this code again. And I put in -4. Okay, it gives us an error message, like error input here. Okay, so this is the way that we have been dealing with error. Like we check if it works or not, and then we proceed with what we really want to do here. Okay, so this is like we are preventing the error before it happens, right? So we prevent the error before we proceed with here, like really calculating the square root. Okay, so we got a question from the chat, like, does it work normally with 0 or error? Good question. So let's have a try. So what if I comment this part, okay, and I run it again, and I put in 0, 0. It works. Okay, so with math power, it works with 0. Okay, so let's move on. So we might want some more, like we might think, is there any other way like we can deal with this kind of error, like how we prevent error before it happens, or like how is there other ways like we deal with error? So we'll introduce another syntax here. So instead of we put in like if statement here, this is new here, throw new error. Okay, so you might not understand it. I'll just put it here and I will explain. So it will be error input, the error message here. Okay. No, I should have put it here in the if statement, right? So we are replacing this line here. We are not randomly throw a new error. Okay, so if x is negative, let's throw an error. Okay, so let's have a try how it looks like, and I will explain. So let's put in -4. Oops, right? It looks like error. Looks like when we have a syntax error, or we put in we are missing some value, or like it looks like an error from JavaScript, right? But the error message here is what we define, like it's error input -0. Okay, so this is the error message that we define. So it looks like an of a developer defined error. It's not JavaScript throwing an error. It's kind of we developers throwing an error here. Okay. So now let's go back to the slide. I will explain further about this. Okay, you just have a glance at how it looks like, and I will explain. Okay, so this is the code that we have already seen. So this is exceptions. So what we just did is we are throwing an exceptions. Okay, so an exception is an action that disrupts the normal flow of a program. Okay, so it disrupted, it's throwing an error message. So this action is often representative of an error being thrown, right? So looks very similar to what we if we have done something wrong, we solve a code, and JavaScript throws us an error. It looks very similar to it, right? So it looks like this. Okay, so exceptions are ways that we can elegantly recover from errors. So it's another way of dealing with errors. So it's a method of ensuring software safety. Okay, so when we are learning about C and yeah, you only learn about C for most of you perhaps. So when we are dealing with error handling, we put a lot of if statements. So if X is negative or if X is positive, and then we dealing with different situations. But now we are introducing another way of dealing with error. Okay, so we got a question from the chat, like exceptions are usually for developers, right? And not for client. Good question. So it's not only for developers. Okay, so sometimes we may have input from client that doesn't make sense. We'll also throw an exceptions, and sometimes we'll see examples later. There are also some exceptions throwing from JavaScript as well. Okay, so we'll see examples. So it's not only thrown by developers. Okay, thanks for the question. And yeah, so we are introducing another way of dealing with errors. Okay, so yeah, and let's see the example first, and I will explain the theory here or the concept here. Okay, so we are through an error here, but we are not really starting to handle it. So the way we handle it is we use a new syntax called try and catch. Okay, so instead of we put an if statement here and see if it works, and then we proceed or not. We try to execute the code anyway. Okay, we try to proceed with the code anyway. And if there's something wrong or if there's an error, we catch it and we stop executing the code further. Okay, so and the syntax we will be using here is called try and catch. And the way we do it is we are going to keep the error here, and what we are going to have is we try. Okay, so we try to do something. We try to get a number from the client. Oops, sorry. What did I do? Try something. Okay, so if it works, great. Otherwise, if there's some error, we catch it. Okay, so we catch the error and we do something. We handle this error. For example, we console log this error. Okay, let's start with something simple. So, for example, error.name and plus error.message. Don't know what is it, right? Fine. Doesn't ever explain. Okay, so this is another way of dealing with error. So we try to do something. Okay, and if there's an error, we terminate the code. Okay. Before I explain further, let's try this code again. Please enter a number. Let's try a 4. Get a 2. No problem. And then let's try -4. Okay, so now it gives us an error message like error and error input here. Okay. So this is how we use exceptions. So for exceptions, we use throw, error, and we use try and catch. Okay. So okay, we got a question from the chat, like when you get an error code, does it usually coming from throwing an error? What do you mean by error code? Do you mean the one like we have seen here? This one is coming from like a developer defined error, like we throw an error here. Okay. Okay, so this is how we use exceptions. So it's a different style of coding. So it's different from what we used before, like if else, and we do different things that we try to do it. And if there's some error, like if there's something wrong within here, and then we catch this error. Okay, so this kind of coding style is called easier to ask forgiveness than permission. And when we say EAFP, okay, so we are mentioning about easier to ask for forgiveness than permission. So it's a quite modern way of coding, like programming. So traditionally, we are using the other way. So not all programming languages support EAFP. Okay, but JavaScript and Python they both support EAFP, and also Go language also support EAFP. And we can say that EAFP is the JavaScript convention for handling errors. But it doesn't mean that we can only use EAFP and we cannot use the traditional way. So we can use both. Okay, so we can still use the traditional way of handling errors, but EAFP is like they have some better like pros here. Like for example, can simplify the core logic, and multiple different sorts of errors can be handled with one except block. Okay, and also sometimes it can be faster. Uh, like the speed performance can also be better sometimes. Um, so the principle of AFP is that it encourages you to assume something will work and just have an exception handler to deal with anything that might go wrong. Okay, so this is EAFP, and the traditional, not tr the other way of dealing with error is called look before you leap. So we call it LBYL. Okay, so this is kind of convention of for avoiding errors in popular languages like C. Okay, so it encourages you to check that something can be done before you actually do it. Okay, it also have some pros and cons. Okay, so for example, the pros is that it doesn't require exceptions, right? So code is structured and therefore easier to reason about. So we have very clear structure. Like if this is in this condition, we do this, and in that condition, we do that. Okay, so it's well structured, but it has some cons. For example, the core logic can be obscured by error checks. Okay, so both LBYL and EAFP, they have some pros and cons. So it really depends on what do you want to achieve. So, but EAFP sometimes can be more efficient in JavaScript. Okay. Yeah, so now let's have another look at exception handling, like have okay, before we have a deeper look at exception handling, we have a question in the chat about the error code. More so when you get error 1562 something like error. Can you clarify a little bit about that question? Okay, we'll move on from now and I will get back. Okay, so exception handling. Okay, so yeah, we have seen this example. Okay, sure. Let's have a look here, our example here. So exception handling is the process of converting a code error message into a user-friendly error message like we have seen. And it's necessary step in development process. It's a pretty popular way. And an exception is actually an object, and it has name and message. So we have seen here. So this error is actually an object, and it has name and error message. Okay, so it has two properties here. So when a runtime error occurs, it stops the code and reads an error object. Okay, so let's have a closer look at the example again here. If I put in -4, it gives a console log error name and error message. Error message is here. Okay, and this is the error name. So to make it look easier, I will put in something like this. So I just structure it a little bit so we can differentiate like which part of it or which part of like we console log is error name and which is the message. Okay, I just have so put in -4. Okay, so error name and error message here. Okay, we got a question from the chat like, does the code keep running after the catch? Good question. It really is a good question. So the answer is no. The code will terminate when it catch some error. Okay, so let's try something here. So what if I put console log code will never run to here if error above. Okay, so let's have a try to run this code. If I put here and I put -4 again, okay, let's see if it console log the string that I put. No, it doesn't, right? So when the code catches an error here, it terminates the code. It will not move on. So this line of code will never be run. Okay, so if there's an error. Okay. We got another question from the chat, like what does ERR refer to? So this is also a very good question. So we can name it at anything. So I put ERR here. So I just randomly put ERR1. Okay, so ERR1, ERR1. Okay, so it's just catching the error object. Okay, so let's I will remove this line. Okay, I will try this code again and put -4. Okay, so you can see that what I put here doesn't really matter. Okay, I can also change it to only E if it looks easier for you. Put E and let's try again. -5. Let's try something different. Okay, so same. Okay, so this is the error object that we catch from here. Okay. Yeah, so we have seen the syntax of try, catch, and the throw new error. So this is how we handle exceptions. Okay. So this try and catch statement is a code or program that handles exceptions. And the try clause runs the code that generates the exception. Okay, so we use the square root here, and it's actually run this function here, right? And the catch clause catches exceptions that are thrown to it, and the throw statement generates exceptions. Okay. We got another question from the chat. Does throw new error need to be defined before try and catch? Then we can define catch error. Yes, we need to throw something first in this try clause, then we can catch it. So if we do not throw an error, so if we do not throw a user define error that we won't able to, not user but developer define error here, we won't catch that error. So we need to define, like we need to throw it first, and then we are able to catch it. But there are other situations as well, like not thrown by our developers, but thrown by JavaScript. Let's have a look at that example. So this is a very good question. Okay, so let's have a look at this example. Okay, so again, we are using PromptSync to get a user input. Okay, and then we have a function called entry check, and what it does is like it asks the user to put in a stage. So for example, the students in primary school, and they are learning some courses, and we say like this course is for stage 5 and above. Please enter your stage before continuing, and then it check the stage. Okay, so let's have a try this code. 7.1 try and catch. Oops. Okay, so let's run this code. It gives a prompt. Okay, so what if we put in 6? Okay, and enjoy the course, which is here. Okay, so what if I put in 3? It will say put in the error name here and error message, and it says error, and the error message, sorry, please try a lower stage course. Okay, so what if I put in something doesn't make sense? So for example, ABC. Okay, it will say error message, please enter a valid stage. Okay, so what if I forgot to import prompt? Okay, and I directly use something like this, and let's make it a little bit smaller and put it. No, it won't work. It doesn't matter. Okay, so let's have a try. Run this code again. Look, it throws me an error that I didn't define in my code. It says reference error, and prompt is not defined. Okay, so this error message is not thrown from my code. It's thrown by JavaScript. Okay, so it still catch an error, but I didn't define this error in my code. Okay, let me have a look at the questions. Is there an error hierarchy in JavaScript? Because the error code is pretty broad, it catch the first error. Okay, so when after it catches the first error, the code terminates. It won't move on to the following code. Okay. Another question is, why is it promoting multiple times? Yeah, I'm also curious about that. Why it's promoting multiple times? Yes, why? Um, let's have a try. I'm also curious about that. Is it because stage check is in Eve? I don't think so. Um, let's put in 4 and promote another time. Why is it? I put in something. This is weird. Okay, so but the key message that I want to mention is here is that we can also get an error from get an exception from JavaScript, and it looks like this, like reference error, and the prompt is not defined. So I'm trying to answer the question like whether we need to define the error before we catch it, and the answer is yes. It needs to be like either thrown by our developers or thrown by JavaScript. Okay. Okay. Yeah. The question, yes. Execution of the current function will stop when we catch an error exception. Okay, and we will not move on to the following ones. Ah, yeah. In the chat, maybe if we move the prompt instead of the argument Eve, why? It's weird. Yes, I agree. Okay, sure. So, okay, so let's get back to the first example that we have seen here. Okay, so yeah, so we have seen like we throw an arrow object, but sometimes we can also uh, throw in other things. So for example, we can throw um, arrow 1, 2, 3. Okay, so yep, let's see how it looks like. Um, is this 5.3 just crash? It's not crashing. I've already put in the try and catch. So let's enter a number -6. Undefined, undefined. Okay, so now you can see the difference here. If I do not put throw new arrow, we are not throwing an arrow object, but we are only having a string. And when we want to console log, we want to use the object like a.name and a.message. It will show an undefined and undefined here. Okay, but we can also have a look. So what if we want to have console log e? So what if I just want to console log this one, npm run, and -7, try something different. Okay, it's still undefined. Okay, so because we didn't throw the new arrow as we had before. Okay, so let's move back to something like this. Okay. Entry check is called at the bottom again, right? We got a question like entry check is called at the bottom again, right? What do you mean here? Let's try something different. I put in a string here before. So what if I put in something 42? Okay, and let's have a look. -9. 42, it console log it 42. It should also work if it's a string actually. A, B, C. -10. ABC. Okay, so we console log E, this error object, it works. But if we want to get the object and property name and a message, we can't catch it. -8. You see, it shows undefined and undefined. Okay, so if we want to use the object properties, the name and the messages, we need to properly throw new error, okay, and have an error message. So for example, input something like that. Okay. Yeah. Okay, so there's something else that we can do. Like for example, we get an input. So for example, -8, and it will return error message. And we can also put in the catch. Like after we console log the error message, we can get another input. Okay, so for example, we ask again for the user input. Okay, and then we console log it. Okay, so let's have a try. What if I put in -7? Okay, it prints out, it console log the error message, and it asks for please enter a number. Again, ask it. So I put in 9, and we got a square root of 9, which is 3 here. Okay. Okay, so we have some other examples in the slide. So this is the one that we have already seen, right? So we console log this error and we ask for input again. Okay. Okay, so here's another example in the slide, which has a while loop. Okay, so let's have a try that code, which is exception 3. Yeah, so this is the code from the slide. So let's have a try it first, and then we have a little look at it. So it's exceptions 3. Oops. 5.3 exception 3. Okay, so let's try putting -5 error when inputting. Ask me to enter a number again. I try -8 again, error when inputting. So again -7 error inputting. So it's a loop, right? Until you put in a proper number, for example 9 here, so the code will end. Okay, so just playing around with this try and catch, and we put in a while loop. Let me have a look at the question in the chat. So the question is, so you could try multiple things looking for an error, almost like a test, but testing user input. Yeah, you can think of it like that way. Yeah, so it keeps running. Yeah, because we are having a while loop. Okay, so we predefined success as false. Okay, so until we make success true, we'll end this for loop. Otherwise, we'll run this loop again and again. It's a loop. Okay. Yeah, so this is this example. So the key points here, exception carry data, right? Error dot message, error dot name. And when the exceptions are thrown, normal code execution stops here. So we have already seen it. If we put a console log like never caught if error, will never be caught. So this line will never be caught. Okay. Yeah, so we can also put exceptions in jest. Okay, so we can use jest to throw error function to test if functions are properly throwing exception. So we can pass it. So we can put in the jest. So let's have a look at this code. Is here. Okay, so this is the square root function. Okay, and we export it, and we try to put it in jest test. Okay, so this is something that we have seen before. Like we expect square root of 4 to equal to 2. Okay, and we expect square root 2 to be close to this. Okay, but we can also test like throws error on negative. Okay, but the syntax here is expect to throw error. Okay, so we are expecting the program to throw an error, and the error message is here like error input is -0. Okay, but we need to be cautious here. Like instead of we put square -2, we put in something looks like this and this. Okay, so the reason being that we cannot expect square root -2 to throw an error. Okay, so we are expecting the function to throw an error. Okay. So we are expecting this function to throw an error. So the syntax is a little bit different from here. Okay, so let's have a try. npm run jest, and this file name is 5.3 catch.test.ts. Okay, it passes. Okay, so this is how we can implement the ingest. Quite straightforward, right? Okay, so this is everything about exceptions. So let's go back to have a look at the slide. So we have already seen this example. Oops, that's it from the slide. Okay, so let's have a quick summary of exceptions. Okay, so the reason we need exceptions is that we are introducing another way of dealing with errors. So instead of how we deal with errors or how we prevent error to happen in C, that we use if, else if, like the conditions a lot, conditional statements a lot. So we are introducing another way of dealing error, which is called easier to ask forgiveness than permission, which is called EAFP. And the other way is called look before you leap, which is LBYL. Okay. The principle of easier to ask forgiveness than permission, the EAFP, is that we try to run something, like we try to run some function, some code, and if there's an error during the process, we catch it. And we define that error like using throw new error. Okay, and this error is an object. It has error.name and error.message. Okay. Um, yeah, so some key terms including try catch statement, right? And we also have the throw statement. And the throw statement throws a user-defined exception. Okay. We can also use JS test with exceptions, and it looks like this. Okay, so yeah, so this is everything about exceptions. So if you have any questions, put in the chat. Otherwise, let's have a quick break. 10 minutes. Okay, and then let's get back and we'll continue with the code coverage. Okay, so let's get back 10:57. Okay, see you at 10:57 and let's move on to code coverage. Put in the chat if you have any questions. Okay. Hello everyone, welcome back. Before we move on to the next topic about code coverage, I want to clarify something about the try and catch. Okay, so we have seen try and catch here. So the flow of try and catch is that the code will first run the code in try. Okay, so first the code in try will be executed. So if there's no error, then catch will never be run. Okay, so as we have seen, like for example, if we enter a number 9 and it will console log the square root, and the catch clause will never be run. Okay, and so which means that the catch will be ignored, right? And if an error occurs, okay, the try clause will stop and the control flow will run to catch. Okay, so if an error occurs in this try clause, okay, the code after the throw error will not be run. The control will be given to catch. Okay, so this is the flow of try and catch. Okay, and the error variable like the E here, we can use any name for it. So for example, we use the E here, and we can also use ERR or just error. Okay, and it contains an error object with the details about what happened. So we have seen example here. So we throw multiple errors here with different error message. Okay, and this error variable or the object, it contains an error object with what happens. So for example, if it catches this error, the error message here will be please enter a valid stage. Okay, so if it catches this error, okay, and the error message print out here will be sorry, please try a lower stage course. Okay. So I just want to clarify this part a little bit. Otherwise, let's move on to the second topic, which is code coverage. Okay, so this will be our final topic on correctness. Okay, so we have so far learned a lot about testing, right? So, and as we all know that testing is very important, right? To make sure that our code is robust and safe, to ensure the safety, right? So, we have learned and used and practiced with many different types of testing. So, how can we know that our testing like if our testing is sufficient or not? Okay, so we are introducing this concept called code coverage. Okay, so code coverage is actually a metric that can help you understand how much of your source code is tested. Okay, so this is basically what it is. Okay, coverage, a measure of how thorough our tests are. Okay. So there are two different types of coverage, like test coverage and code coverage. So what's the difference? Test coverage is a measure of how much of the feature set is covered with tests. Okay, so it's like the percentage of feature sets. And this is often left to human judgment. So for example, if you have tested like whether the user input is valid, whether you have tested whether the square root is correct or not, whether you have tested other. So it's like how much of the feature set is covered. Okay, but there also the code coverage. So the code coverage is how much of the code is executed during testing. Okay, so for example, when we run the testing, we are testing the code in our we are executing the source code when we are testing, right? So it's measure how much of the code is executed during testing, and this can be computed and quantified. Okay. So it's a very useful metric that can help you assess the quality of our test suite. Okay, so it's the coverage is a percentage of statements, lines, but more. Okay, we'll see examples. It can give us a good indication of how much of a code is executed by the test, and most importantly, highlight what hasn't been executed. So, which means that the part of code that we are not testing, which may cause issues. Okay, so this is why it is important. Okay, so now let's have a look at how we get the code coverage. Okay, so for different programming languages, we have different tools to help us calculate the code coverage. Okay, for JavaScript, we have something that we can use with jest and this dash coverage flag. So the way we calculate code coverage is by we found off a package.json file in our project. Okay, and we had jest here, right? So we put in something dash coverage. Okay, and this helps us to calculate the coverage of our like code coverage of our project test suites. Okay, let's have a look at some examples. So this is something great with JavaScript. It's very easy to use, like very easy to get code coverage, and it's specifically for JavaScript. So, but there are also other different tools for different languages. So, yeah. So let's have a look at an example, which is this one. So this is a function helps us to identify if a year is a leap year. Okay, so for leap year, we actually have some rules to identify whether a year is a leap year. So this is the rules. Okay, so a year may be a leap year if it is evenly divisible by 4, and years that are divisible by 100 cannot be leap years unless they are also divisible by 400. Okay, so if a year satisfies both the rules above, then it is a leap year. A little bit complex, but yeah, good news is that we already have the code here. So now let's have a look at this code. Okay, so before we have, so in this function we have a lot of if, else, and else. So it's a good opportunity to catch up with the basics. Okay, so we talk about the if statements in JavaScript and other things. So I'll put it here. Just to have a quick recap of what we have learned before, but I'm sure you might also be very familiar about this. So like if a condition, so this block of code to be executed if condition 1 is true. Okay, and this block of code to be executed if the condition 1 is false and the condition 2 is true. Otherwise, the block of code will be executed here if condition 1 is false and if condition 2 is also false. Very basic stuff, but very important too. Okay, so good opportunity to recap. Okay, so now let's have a look at this code. If a year is not divisible by 4, it will directly return false. Okay, so it means that it's not a leap year. Right, so if it's divisible by 4 and not divisible by 100, then we return true, meaning that it's a leap year. Okay, so if a year is divisible by 4 and divisible by 100 and also divisible by 400, it will be true. Otherwise, if a year is divisible by 4 and divisible by 100 and 400, it will return true, meaning it's a leap year. And so, if a year is divisible by 4 and divisible by 100, but not divisible by 400, it'd be false. Right? Is that right? Yes, it's right. So, so this is why these century years cannot be leap years, right? And there are also examples. These years were not leap years, but these were. Yes, yes, right. Okay, so let's have a try run this code. npm run ts node, and this is 7.1 is leap year .ts. Oh, there is nothing because we are not really, so we need to console log this function is leap year. Okay, we put in a year, for example, let's have a try to 2020, right? And see if it's a leap year. It's true, right? It is a leap year. Okay. Now let's have a just test for this function, and let's have a look at code coverage. Okay. I already had a just I should put it here. So did we export it? Yes, we export this function and we import it from this file and have something for the test. So for example, let's try something like recent year. So what about we expect is leap year 2023? So this year, it should not be leap year. Okay, so we are expecting it to return false. Okay, and 22 expecting it to return false, and 2020 we are expecting to get true because it should be a leap year. Okay, so because we added in our package JSON just like dash coverage, we should be able to get something. So let's have a look. So this file is 7.1 is leap year. Yes, this is okay. So now we get something like we get a table here we have never seen. Okay, so this is something that we got from the dash coverage. Okay, so Yeah, so JS comes with this functionality of generating this report, which helps us to understand the test coverage. So it comes with JS. And this coverage includes something like, for example, statement, branch, function, lines, and uncovered lines. Okay, so what do they mean? So what it tells us, what are they telling us? Okay, so let me make it a little bit bigger and do this again. Yeah, so here's the file. So this leap year test you only run this file. So we only have one file here. Okay, and the statement coverage is 66%, and branch coverage is 50%, function coverage is 100%, and lines coverage is 66%. And we also have some uncovered lines in this leap year TS file. Okay, we got a question in the chat. So the uncovered lines are untested. Yes, the answer is yes. Okay, so let's have a look at these first. Okay, so we have statements, branch functions, and lines. So function coverage is 100% here. So function coverage means that like how many of the functions defined in this file have been called in the test. Okay, because in of a leap year file, we only have one function. Okay, so it's 100% coverage. Okay, and lines coverage, we can see that it's 66% coverage. So lines coverage means like how many of the lines of the source code have been tested. So meaning that how many of the lines. So this is one line, okay, two lines, and three lines. Okay, so this is the line coverage. Okay, and we also have something called statement coverage. And in this example, we can see that statement coverage is exactly the same with line coverage. Okay, so what is statement coverage? So statement coverage is how many of the statements in the program have been executed. Okay, so a statement is a single line of code that performs a specific task. Okay, sounds a little bit similar to lines. Okay, so statement is a single line of code that performs a specific task. So now this line performs one task and this line performs one task. So perhaps we may have some pretty bad, or for some reasons we have this kind of coding style. We merged these two lines together. Okay, so we put return true here. Okay, so now let's have a look at it again. Yeah, so this doesn't make sense. I need to do something else. So what if I put something like, because it's, which one? 16 to 18 wasn't run. So 16 to 18 wasn't run. So I should move something outside of these lines and see the difference. Okay, so what if I have something like this? Okay, so now you can see the difference. Like lines coverage and statement coverage are now different. Okay, so statement meaning that a single line of code that performs a specific task. And in this line, is performing two different tasks. Okay, so it's actually two statements here in this line. Okay, but line coverage doesn't care about that. It's just calculating how many, what is the percentage of lines that is coverage in the test suite. Okay, so this is the difference between statement coverage and lines coverage. Okay. So this is the difference. And now we are moving to the last one, which is branch coverage. Okay, so this might be a little bit confusing, like it's very different from the branch in Git. So in Git we have branches, but this branch is a different branch. Okay, so the branch here means it's talking about the control structure. So for example, the if statements. Okay, so how many of the branches of the control structure have been executed? So for example, this is or this one, or this one, or this one. Okay, so this is the branch coverage. So for example, given an if statement here, okay, have both the true and false branches been executed? So whether all of the if-else conditions have been executed during the test. Okay, so this is the branch coverage. So this is how we look at the code coverage in terminal. But we have another way of easier way to look at it. So visualize it. So we have a new folder like we haven't seen before coming up here, which is called coverage. It's here. Okay, so this is automatically generated when we run just dash coverage. Okay, so we can have a look at it. So we got a folder called LCOV report. Okay, and we also got some other files in it. And the one that is useful is an HTML file in this folder. So what I'm going to do is I'm going to open this folder from this project, and I will find this coverage folder here, coverage. I open it, okay, and here is a LCOV report folder. Okay, so within this folder, we have some date is leap year HTML. Okay, I click on it. So this is, I should, sorry, I will close it and open it again. Is leap year. Okay, it shows us like which line was not executed. Okay, so it's easier to visualize it. We got a question in the chat. Where is the lecture code shared for week 7 and week 5? I think we have a folder in WebCMS. Like there's a link in WebCMS that we share code in it. 5 and coursework lecture here, and we share code here. You should be able to find code here. Otherwise, all the code is in the slide. Okay, but you can still find the code here. Okay, so let's get back to this code coverage. Okay, we can also visualize it. Looks like this. Okay, so this is the file that our test suite called. Okay, so we have statement coverage, branches coverage, function coverage, and lines coverage, which is actually the same as what we have seen here. Okay, but it just visualizes things. Okay, it also shows us, like for example, here we have 9 statements and 6 of them have been executed. I'll make it larger. Okay, it's easier to look now. And we have 6 statements have been executed during the test, and same with functions and lines. Okay, we can also click on this file. Okay, and make it a bit larger. Okay, so we can see that we have an E here. So E here means that this else statement, else pass not taken during the test. Okay. And we also have 1x, 7x, 5x. This means like how many times this line have been executed during the test. Okay. So it's pretty easy to visual. It's easier to understand with this kind of visualized HTML. Okay. Sometimes we may also have a seen an I here. So similar as what we have seen E here, we may have an I here if this if statement hasn't been executed during the test. Okay, and the code that is colored in red is not executed during the test. Okay. So this is how we rate the report, the code coverage. Okay. Okay, so let's do something and try to make the code coverage better. So let's go back to the test, which is here. So we just randomly tested some recent years. And we can see from this report that this else statement wasn't tested. Okay, so this if the year is divisible by 400, it's not tested. So what about we try something, for example, we test divisible by 400. Let's try that. Yeah, okay. So let's try something. For example, 2000. Okay, so year 2000 should not be leap year. Oh, they are leap year, right? It is leap year. For 2000 is leap year, right? Is it? Should be. So let's have a try. Yeah, you can see it's better now, right? So we have lines coverage and the statement coverage, branch coverage was pretty low, and now it's getting better. Okay, so let's go back and have a look at this HTML file again, and I can just refresh it. Oh, I didn't refresh it, it automatically refreshed for me. Okay, so we can see that performance is better now. Okay, so I can also go to this report and see. Okay, so we got the divisible by 400. We run this line, but we haven't tested if the year is not divisible by 400, but divisible by 100. So this is how we can visualize things. Yeah, so pretty straightforward, right? And also we can also tell which line is uncovered from our test sheet. Okay. Let's add another one. So what about test? Let's try divisible by 100. Okay, divisible by 100. Let's try which one? 19? Perhaps is it true or false? It's false, right? It's not the leap year. because it's divisible by 100 but not divisible by 400, right? So it's not a leap year, it should be false. Okay, so let's run this again. It's 100. So all the lines have been covered in our test suits now. Okay. Cool. Let's have a look at our slide here. Okay, so this example, and okay, so here's another example that we can play with. Day to year. Okay, so this is the one. So given a number of days from January 1st, 1970, and return the year. Okay, so if there's no leap year involved, we can just calculate like how many 365 are there from the first day of 1970. But sometimes we may have leap years in the middle, and there will be 366 days in that year. Okay, so this is like given a number of days from January 1st, 1970, and we return the year. So let's have a test sheet for this one. So let's start it with some easier one, like test without leap year, and this year is close to 1st of January 1970. So what about 10 days after 1st of January 1970? It should still in the year of 1970, right? Okay, so let's have a try. It's 7.1 day to year. Okay, so here's something interesting. All the tests passed, okay? We only have very simple tests here, okay? But different from the one that we have seen above, two files are executed during the test, okay? The reason is that in this, I'll close this file. Close that one. So in this day to year, where's my day to year? Day to year. Okay. So in this day to year, we are calling another file in is leap year. Right? We are calling this file. So two files have been tested. Okay. So we are looking at the coverage of two files here. One is 1.7 day to year, and the other one is 1.7 is leap year. Okay, and we can have a look at the coverage. The function is 100%. Yes, and a line. So this first line here means the overall coverage, and the two below are detailed code coverage for each file. Okay. Okay, so two files here are being tested for coverage. Let's have a look at the visualize. So day to year here. Okay, so now we are also able to see two files here in this HTML file. Okay, so let's have a look at this first one, day to year. All right. So we can see that none of this if or else statement was executed. So we can see that this if pass not taken. So we have seen an I here. Okay, we got a question in the chat. What was the link to this? So the link to HTML, right? Yes, I know sometimes it's a little bit confusing here. So it's in your project folder. Okay, so my project code folder called COMP1531. And after you run the just dash coverage, it will automatically have a new folder called coverage in this project folder. You click on this coverage and you can see another folder called the report. You click on it and you find the one that you want. Okay. And now we are looking at the day to year. So I click on the day to year and this is what it shows us. Okay. And you can click on this all files at the left hand side. It will visualize. It looks like this. And you can click on any of the files here and to see more details. Okay, so let's have a look at this here. Okay, so we have seen the E before, right? When the else branch was not tested, we have seen an E. Now we have seen another I. So here's a good example that we can see the I, like the if path not taken, and all the right lines are not tested during, it's not covered. Okay, and let's have a look at if leap year. It's the same, like the if statement not tested and the else path is not taken too. Okay, so let's have a look at this code. So let's add something to our test. Okay, so what about let's try to add some date that is not that close to 1970. Okay, so let's add something. For example, year, not that close to 1970, but also not too far. Let's start with simple ones. Okay. So let's just copy and paste. It's much faster. What about let's try something 380? It should be the following year, right? Yes. Okay, so let's have a try this one. A little bit better, right? The code coverage now is a little bit better. So you can see, right, the lines coverage has improved, the branch coverage is improved, and also the statement coverage, right? We got a question in the chat. Does right mean never covered? Yes. The lines that colored in right means never covered during the test. Okay, so let's add something more. Okay, so before we add, let's have a look at which line of code that we never covered. So we can see that here, we never covered the if statement, like if there's a leap year. So we have never covered that. So let's try to add some tags that cover some leap years. Okay, so let's just copy and paste, it's faster. Okay, so I will result I change to width. Okay, with leap year. So let's try. So when is the leap year? 1980 is a leap year. Okay, so it's 10 years away from 1970. So what about we put 365? I randomly add some 50 days. Okay, it should be in 1980. Right? Plus 1. Just to be safe. I add a lot more days, add 50 days here, just to be safe. Okay, so it should be in the year 1980. Okay, so let's have a try. Oh, one failed. It's not 1980. Which year is it? Received 1971. Oh, yes, the reason is that it should be 10 here instead of 1, right? Okay, so now let's try again. Okay, it passed. And we can see that all the lines and statement functions have been covered in this file. Okay, but not all the code coverage still need to be improved for the if leap year. Okay, so we might need other test suites for it. Okay, all good? Okay, so these are the two examples here. But now we can also go back to have a look at our jest test for our exceptions example. Okay, so in the question from the chat, do we need to do this for iteration 2? Yeah, the answer is no. It's optional. Of course, you can practice it for iteration 2, but it's not required. But you will starting to see practices on code coverage in iteration 3 and also lab 8. Okay, so you're starting to practice code coverage. Okay, so let's go back to our example. So here we have the square root function. We also had the test here for that square root function. So let's have a look at its coverage, test suit coverage. Okay, so the file name is what is the file name? Catch. Okay, 100%. Yes, all the lines, all the functions have been covered in this test suite, which is great. Okay, so you can simply add in your package.json file -- coverage, and you will be starting to see your code coverage in your test suite. Okay, yeah. Question in the chat. It doesn't check all our files in iteration 2. Yes, because we'll need to add some extra lines here in this package.json file, but we will add that for your iteration 3. Okay, so you do not need to worry too much about that. And another question in the chat, are there no labs this week? Didn't find the lab 7. Yes, you are right. There's no lab this week. And your tutors and lab assistant will be helping with your iteration 2 projects during your tutorial and labs this week. Okay, so we'll be focusing on iteration 2 this week. Should we be aiming for 100% coverage? This is a super, super good question. I was starting to talk about that. So there has always been the question like what percentage of coverage should we aim for? And there's no answer, like there's no single answer to it. Okay. We may assume that they have a percentage of coverage would be great, like at what we have seen here. So we might have seen that but in reality, it's not always the case. Okay, so sometimes we are trying to add a lot of tests to make sure that our code coverage is great. But sometimes they may cause problems as well. So you might add some redundant tests, or it might be too complex, make your test too complex, and it's time consuming as well. So normally we can say that it's generally acceptable if 80% of coverage, okay, code coverage at 80% would be a good one. Okay, so it's a good goal to aim for. Sometimes when you just started with writing a test, you may find that the code coverage will be pretty low. like what we have seen here. So it's totally normal. It's totally fine. So you'll be adding tests to your test sheet slowly, like really, and your code coverage will be getting better and better. Okay, so it's very normal. Like we start with a fairly low percentage of coverage, and you do not need to have too much pressure to reach to 80% of code coverage straight away. Like sometimes if we rushing into a coverage goal, might push our team to write some tests that doesn't make much sense. Okay, just only aiming at code coverage and without good rationale behind it is not a good practice. Okay, yes, I think other than concerning about code coverage, it's more important to think about like what you need to test, like what is important things that we need to test. Hmm. I hope that answers your question. But in general, like code coverage is good too to help us identify parts of a code that hasn't been tested, um, because those parts of the code will be in risk. So it's more important to look at the code that we haven't tested. Okay. So it's kind of providing us an action or actionable guidance, like which part of the code, like we need to look at it and see if we need some more tests for it. And we can also say that good coverage doesn't equal good tests. Okay, so to have a good test, there are many things that we need to consider, like the features, like we have mentioned earlier, like whether we are testing all the important features. Okay, so that is also important. And also comparing the different types of code coverage, like the statement coverage, branch coverage, function coverage, lines coverage. Um, Comparing this, um, I would say branch coverage is more important than, for example, lines coverage. Okay, so there are some if conditions which might be missing from our test. So it's more important to have a look at the branch coverage. But this part is quite useful, like uncovered lines. Okay. Okay, let's have a look at the slide and see where we are up to. So this example, we have already seen it. Okay, so run just dash dash coverage to run test with coverage on. Okay, you can always turn that on. And recommended to put in the package.json script. Yes, of course. And you can access an HTML summary in this folder, in this field. Yeah, you can find the link here. Okay, so it's in the coverage folder, and then there's report folder, and it's called index.html file. Okay, so you can also find that from VS Code is here, right? It's in the coverage. Okay, and it's index.html. You can also look at the code here. So, but this one is not visualized. We only look at the HTML file. Okay, but if we want to really open this HTML in our web browser, I would recommend you to open this folder and find index.html or the specific HTML file that you want to look at. Okay, and for so this is our last. This is the last one that we look at it, which is the score. You can see that all the lines have been tested. Okay. Any other questions? Okay, so here in the slides, you can see more details about the branch coverage. It's different from gate branch. It's for if like example, like most oftenly used is the if statement, like whether all the if statement, like else statement, have been checked. Okay. Sometimes we also refer it to as age coverage. I know this figure is not very clear. I don't know why it looks like this, but it's just showing us like the why we call it as age coverage sometimes. Like for example, if we have only one single statement A, like we only run A, and then this is sequential. Like after A statement, we run B statement, but sometimes we have like if A then B. Otherwise, if it's not A, then skip B. Skip the B statement here. And here, if A, then B, else C. Okay, if A, and then we can go to B. Otherwise, if it's not A, then we go to C. Okay, well, A to B. This is a loop. Okay, so this is sometimes we call it like age coverage. Okay, so if it covered all the ages in our program. Okay, so this is the branch coverage checking. All right, so here's the summary. Like code coverage is useful, of course. It tells us like how sufficient our test suits are. Okay, it also helps us to find code that has never been tested, which is risky. And it's more important to look at what's not covered than the coverage percentage. Yes, definitely. Branch coverage is a more accurate measurement, so you should use it instead of statement coverage. Absolutely. So branch coverage is also sometimes we got quite low score for it. Okay, so branch coverage. And like all measurements, it's important to understand what meaning to attach to it. Yes, exactly. So we need not only that we aim for good code coverage score, we need to know what we are testing and why we are testing it, and if we are testing all the important features. Okay, it's not only about the coverage, code coverage, the score to it, but also the meaning to our testing. So like why we are testing, what we are testing. Okay, great. So till now we've covered everything about correctness. Yes, and everything that we are talking about today will not appear in your labs or projects straight away. So this week, it will start to appear in your labs or tutorial or projects from next week. Okay. A question like what lines do we need to add to package.json to test iteration to coverage? Which is a very good question. Uh, it's a pretty long line. I can't remember it. But please put in your question in the forum. Okay, and we'll if you want to test your iteration to coverage, feel free to use that. We'll put the answer in the forum. Okay, so yeah, and yeah, please, get started with your iteration. Not get started, but make your progressing well with your iteration 2 this week, and make good use of our help sessions and our tutorials and the labs this week to get some help, some assistance, or some support for your project. Okay, I would say iteration 2 is pretty important. Please do not fall behind in iteration 2. Okay, get ahead instead. Okay, yeah, so tomorrow we will have in-person lecture again in the Science Theater, and we will be talking about some very, very, very interesting topic. which is deployment and conceptual modeling. Okay, I'm super excited to talk about these two topics tomorrow. So yeah, I will see you tomorrow in the Science Theater. Okay, please progressing with your iteration too and get some help, some support from us. Okay. If you have any other questions, please put it in the forum. Thank you, everyone. Thank you.